37. So these isotopic form of chlorine occur in nature in the ratio of 3:1. In the ratio of 3:1. So when you consider this chlorine, atomic number is same, different mass number 35 and 37. So how we take the mass of chlorine atom? What we have to consider? Whether we have to consider 35 or the 37. So if the atoms, if they have different mass number, so to calculate their mass, we are taking average mass. We are calculating average mass of the atom, average mass. So how to calculate this average mass? As I said, chlorine 35 and chlorine 37, they occur in nature in the ratio of 3:1. In the sense, 3 part is chlorine 35 and 1 part is chlorine 37. If you say in percentage, which means 75% chlorine 35 is present and 25% chlorine 37 is present. 3:1. So, to calculate average mass, while calculating average mass, which is equal to, that is atomic number, mass number of chlorine 35, that is 35. This is the mass number of this first isotopic form into which is present at the percentage, which is present 3 part. In the sense 75% it is present, that is 75 divided by 100 plus second isotopic form chlorine 37, that is 37 into 25%, 25 divided by 100. Simplify this, which is equal to 25 3s are 25 4s are 25 1s are 25 4s are 35 into 3 by 4 plus 37 into 1 by 4, which is equal to multiply 5 3s are 15, 1 carry, 3 3s are 9 plus 1 10, 105 divided by 4 plus 37 divided by 4, which is equal to 130, 140, 142 divided by 4. That is 4 3s are 12, 2 carry 22, 4 5s are 20, 2 carry 5. That is 35.5. The average atomic mass, 35.5 atomic mass unit. Average atomic mass of chlorine is 35.5. In this way, we can calculate the average mass of isotopes. Isotopes average mass. Since they have different mass number, their mass numbers are different. To consider the mass, we have to calculate average mass. We can't say this is the mass of chlorine 35 or 37. So in that case, we have to calculate average mass. By calculating average mass, you should know how much percentage these isotopic forms are present. So when you consider chlorine, it is present, that is chlorine 35 is present. Chlorine, the ratio of chlorine 35 and chlorine 37 is 3:1. That is 75% is to 25%. So first atomic mass number of chlorine 35 into 75 divided by 100 plus second isotope 37 into 25 by 100. Simplify this, you will get the answer 35.5 atomic mass unit. In this way we can calculate the average mass of isotopes. So in the same way, related to this, one question is given in your exercise, that is page number 55, exercise question. What is given in that? In that they have given, that is question number 11, 11th question. Question number 11, page number 55, exercise question of that lesson. Question number 11, they have given the average atomic mass of an sample X, and average atomic mass is given. Average atomic mass of sample. So they have taken sample in gender X. The name of the sample is X, which is 16.2 atomic mass unit. 16.2 what are the percentage of, there are two isotopes 8x16 and 8x18. We are going to calculate percentage of isotopes, percentage of 8x16 and 8x18. How much percentage they present in the nature, that we have to calculate. So, for this purpose, first I take let solution. Let the percentage of 8x16, that is x16 eliminated, they have taken x. 8x16, the percentage of 8x16 isotope, I will take it as x, let it be x percent. Now, therefore, the percentage of 8x18 isotope. So, how much this? Percentage of second isotope. First one I have taken as x. So, it is calculated for 100. If first one is x, second one will be 100 minus x. Remaining part 100 minus x. Now, we will go for the calculation. Average mass, which is equal to what I said, atomic mass, that is the mass number of first, that is 16 into its percentage, that is x percent, in the sense x divided by 100 plus second one 18 mass number into what is that, 100 minus x percent divided by 100, which is equal to 16 into x, 16x divided by 100 plus 18 into 100, 1800 minus 18x divided by 100. We'll solve this. Continue. 16x by 100 plus 1800 minus 18x by 100. So, denominator is same, that is which is equal to 100. Numerator 16x plus 1800 minus 18x. But what is the average atomic mass, which is given in the question? How much average atomic mass they have given? 16.2. 16.2. Now cross multiply. So 16.2 into 100. 16.2 into 100, which is equal to 16x minus 18x, in the sense minus 2x plus 1800. When you multiply 16.2 into 100, you will get the answer 1620.0. In the sense 1620, which is equal to minus 2x plus 1800. Now minus 2x bring this side, it will be plus 2x, which is equal to 1800. This 1620 take to that side, it will be minus 1620, which is equal to, now subtract this, 0 minus 0, 0, 10 minus 2, 8, 7 minus 6, 1, 180. That is 2x equal to 180, therefore x equal to 180 divided by 2, 2 ones are 2 90s, that is 90. But what is x here? We have taken x, percentage of, what is that? 8x16. 8x16. How much? That is taken as x, we got it 90%. What about the other one? What is that? Therefore, percentage of second element 8x18 isotope, which is taken as 100 minus x. 100 minus x is 90, we got 100 minus 90. That is when you subtract this from 100, because in the beginning itself we have taken the first isotopic form percentage, if you take it as x, second one will be 100 minus x, because we are calculating for 100. So the answer will be 10%. There are some elements in nature. For example, if you take calcium and argon. If you take these two elements, calcium symbol is Ca, the atomic number of calcium is 20. If you take argon, its atomic number, argon symbol Ar, atomic number argon is 18. But mass number, calcium mass number is 40. In the same way, mass number of argon is also 40. So these two elements, they are the two different elements. This is calcium, this is argon. They are the atoms of two different elements. This is calcium, is different from argon. But what you can see in this case, we can see here, they have different atomic number. Their atomic numbers are different. This is 20, this is 18. But what you can say about mass number, this is also 40 and second one is also 40. So these type of elements we call them as isobars. So isobars are the elements of, they are two different elements. Isobars are two different elements with the same mass number, different atomic number. Same mass number, different atomic number. We call them as isobars. Isobars are two different elements